All right, today we are going to talk about something called the natural logarithm. So, a natural logarithm is an inverse of a log that has a base of e. Okay, so we talked about base e when we were doing exponential functions. Okay, and then you guys just read about the review on an exponential function. So, we remember that e is that irrational number, 2.7182818. Okay, and then when you're talking about inverses, we know that on the graph, they're going to be reflections over that line, y equals x. Okay, so the inverse of the natural base e is a natural logarithm. Okay, you can write it as log base e of x, but the proper way to write this is ln x, and that is called the natural log of x. Okay, so on our graph, the natural log is this function here. Okay, and it is log base e of x, but we write it as the natural log of x. Okay, and then this is your function y equals e to the x that we talked about in chapter 7. Okay, so today we're going to write equivalent exponential functions. So an example that they give you is the natural log of 6. Okay, so if you have the natural log of 6 equal to x, that is the same thing as log base e of 6 equal to x. Okay, and then based on what we did earlier in this chapter, we're going to write that in exponential form. Okay, so I want you to take this and see if you can rewrite that in exponential form. So remember your base, your answer, your exponent. Your base, your answer, your exponent. Okay, so our base is e, so we can write it as e to the x equals 6. This is your exponential form. Okay, and then we can also go in the other direction. So if they give you e to the x equals 0.5, then we can write that as log base e of 0.5 is equal to x. Okay, and then we are going to write that as the natural log of 0.5 equals x. Okay, and then this is your log form. Okay, so the natural log is a type of log. It is just a log with a base of e. Okay, which means all of the same properties that apply to logarithms with base b are also going to apply to the natural log. Okay, so we're going to write each exponential equation in logarithmic form. Okay, so you're given exponential, you have to write it as a log. So when it's in exponential form, you can see what your base is. Okay, so we can write this as log. We're going to write it as base e first. Okay, log base e of 45 is equal to 3x. And that's just based on our definitions of logs. Okay, whenever I'm going from exponential to log, okay, I always remember to myself that it equals the exponent. You guys can probably tell I like alliteration to help me remember things. So equals the exponent. So if my exponent is 3x, I know I can set it equal to that. Okay, and then this is written, instead of log base e, we just write that as the natural log of 45. So this is going to be your log form. Okay, so for b, again, you have your base of e. Whenever your base is e, that means you're going to write this as the natural log. Okay, so see if you can use what we did in part A to help you rewrite part B. Okay, so you need to write that in logarithmic form, so you should have the natural log somewhere there. Okay, so we're going to have the natural log. This means your base is e. I told you that it was equal to the exponent, so it should be equal to 5. And then you have x plus 1. If it's a binomial, you can't write it like this. You have to put your parentheses on there. Okay, so anytime it's a binomial, you're going to have to include the parentheses so that it means the natural log of this quantity, x plus 1. If you don't have the parentheses, then it's just the natural log of x, and then you're adding 1 to that value. Okay, so they do mean two different things. All right, and then example 2, we're given the log equation, and then we have to write it in exponential form. Okay, and that's where you can think of your base, your answer, your exponent. Whenever you see the natural log, we know the base is e. Okay, so it's your base, your answer, your exponent. Okay, so e is your base, the exponent is 2x, and it is equal to 36. Okay, and then go ahead and do part B if you haven't already. So your base, your answer, your exponent. Okay, so your base is e, it would be raised to the x power, and you have 0.002. Okay, that would be your exponential form. All right, now we're going to write each expression as a single logarithm. Okay, so you can see you have the two natural logs here, two natural logs here, two natural logs here. In order to write it as a single logarithm, we are going to use our log properties. So remember, we have the product property, the quotient, and the power property. Okay, now when you're using these properties, you can use them forwards and backwards. So the way we're going to use it today is we're going to look for values in front of the natural log to see if we can write those as powers. So you are never going to leave a value in front of your natural log, okay, in front of ln. Because if you have a value in front, you can rewrite that as an exponent. Okay, so we actually see that in part A. In part A, you have this 3 in front. Okay, this is going to be an exponent. So we're going to rewrite this as the natural log of 3 cubed minus the natural log of 9. Okay, on your homework, you are not going to have to write that this is the power property. On your notes, I want you to do that so you know how we're going from step to step. Okay, and then if you have 3 cubed, we can just simplify that to 27. Okay, and then because we have the minus, that's going to be your quotient property. So we can divide 27 by 9. Okay, and that actually does simplify to 3. So this will be your final answer. Okay, so we use the quotient property and then simplify. All right, so based on that, I want you guys to do part B. Okay, so last time we started with the power property. Could we use the power property again for this one? Could we use the power property again? Yes, so this would be the natural log of x squared plus the natural log of 4 squared. Okay, and you do need to like write out your different steps. It's okay if you combine the next 2 steps into one, because 4 squared, you know, is 16. So if you just want to multiply 16 times x squared, okay, I'm fine if you take that down to 2 steps. Okay, if you have a couple more, because you do the x squared times 16 and then write it as 16x squared, that's fine. You can write this with parentheses or without. For this, it doesn't matter because you only have one term. So if you just have one term, you don't need the parentheses. They're optional. But if you have something added, if you have a binomial, that's when you have to include that. Okay? All right. Now for part C, we're going to do most of this without a calculator because I'm going to show you some different ways that you can think about this. In the spring, a lot of you will be taking the SAT and the PSAT, and so these different applications and different ways of thinking are gonna help you with that. So the first step is, again, anything that's in front we're gonna write as a power. So we're gonna do the natural log of 1/3 to the 4th minus the natural log of 1/9 to the 6th. Okay, so when you simplify, 1 to the 4th is 1, okay, and then you have 3 to the 4th, which, what's that going to be? 81, good. So that's something that we're familiar with. Now, 9 to the 6th is really big, so we're not going to use our calculator yet. Instead, we're just going to simplify. So 1 to the 6th power is 1, and we're going to leave this as 9 to the 6th power for right this moment, just so I can show you a different way that you can think about this. So when you have division and you have 2 fractions, okay, the minus is going to be the quotient rule. You have the natural log of 1/81 divided by 1/96. Okay, so we did the power property. We simplified. And now we're going to use the quotient property. Okay, now the reason I wrote it like this is because when you have fractions, you guys remember when you're dividing fractions, what's your rule? keep, change, flip, right? So you have 1 over 81 multiplied by 96 over 1. Okay, before we go to our calculator, let's use our rules of powers. This is 9 to the 6th. 81 we can rewrite as what? 9 to the 2nd. So if we think of this as 9 to the 2nd, then how can I simplify this here? Oh, sorry, I wrote the answer. Right? So this is 9 to the 2nd. You can subtract it and it would be 9 to the 4th. Okay, so 6 minus 2 is going to be 4. So natural log of 9 to the 4th. You could do all of that without your calculator. And then 9 to the 4th is pretty big, so I would let you use your calculator if you were doing that. 81 times 81. Okay, and then 9 to the 4th, what did you guys get for that? 6,561. Good. Okay, and then that would be your final answer. So when you do your assessment for Chapter 8, you're going to have part that's calculator and part that's no calculator. So when you're doing your practice problems, I'm going to let you use your best judgment. Like you can see these we're doing without a calculator, but when you get into the bigger numbers, that's perfectly fine for you to use it, okay? All right, and now we are going to do some more solving. So yesterday we learned how to solve with logs, and yesterday we were using the common log. So whenever you're solving an exponential equation, we are going to be using logarithms. Okay, that's what this chapter is about. Can you solve with logarithms? So yesterday we used the common log. Today we're going to use the natural log because we're solving equations that have the base of e. So we learned today that the inverse of e is the natural log. Okay, which is ln on your calculator. And we're going to use that to solve. And just like we did yesterday, you always want to isolate that base value when you are solving. Okay, and you are going to be isolating, when we say isolate the base, this is what you're going to get by itself. Okay, this is what you're trying to isolate. Okay, now some of your equations contain logs. So if you have a log in the equation, you are going to solve those by writing the log in exponential form. Okay, and then I put an important reminder here for you. So you're going to have to show all of your work with logs in order to get credit. Okay, being able to write out those stats is going to be really important as you're moving up in the higher level math. Okay, and so remember that if you have the natural log of y equal to x, the way that you write that in exponential form is with your base. What's your base of the natural log? No? E, yep, so the e to the x equals y. This is your exponential form. Okay, and yesterday we had different bases, so we didn't have base e, but we had different bases, and we had to write it in exponential form. Okay, so today you're going to see some of that as well. All right, so example 4, it just says to solve each equation, we're going to round to the nearest 10,000. And then we're also going to be writing these as an exact value as well. Okay, so like I said, you'll have part of your test that's calculator, part that's no calculator. So the no calculator part is writing exact answers. So we're going to start practicing that. Okay, so to help us prepare for that, we're going to write each solution as exact and rounded. Okay, we're going to write each solution as exact and rounded. Okay, so in part A, we have an exponential function. How can we tell what an exponential function is? What's the key characteristic of an exponential function? Yeah, the power has your variable in it. Good. This one has the power of x. So if you have e to the x, then what you're going to do to bring that down is you're going to do the natural log of both sides. Okay, so we're going to write that part out. And then when you take the natural log, what we're allowed to do is use that power rule, which leaves you with x times the natural log of e. What's the natural log of e? The e is the 2 point whatever. Let's do it. Actually, let's do it in our calculator. It is. So the natural log, remember, if you have the e, it's just e to the first. Okay, so it's 1. Why is it 1? When do you get a 1 with a log? Whenever you have what? Why is that 1? What's special about e and then the natural log? Yeah, so when the base is the same as what you're taking the log of, it's going to be 1. Okay, that's why if you do your log of 10, the base is 10, that's why it's 1. Okay, so you can think of those as canceling each other out. Okay, so if I do x times 1, I just get x. So natural log of 5.8, that's going to be my exact value. And then we're going to round it to the nearest 10,000. So the natural log button is right underneath the log here on your calculator. So we're going to do the natural log of 5.8. So 1.7579 is what you would have rounded. Okay, so an exact answer is not a rounded value. Okay, so if this were on a no calculator section, you would just write the natural log of 5.8. This is asking you to round to the nearest 10,000, so we're going to write it as 1.7579. That's just to help you differentiate. Yep, so on like the calculator section, you just have to round it on the other one. Okay, and then for B, again, you have this e to the x here, but it was already isolated in A. We're going to have to isolate it in B, which means we're going to have to move these numbers over. So we'll start by subtracting 3 from both sides. Dividing by 5. And then once you have that isolated, you can take the natural log of both sides. So you do need to write out that step that you're taking the natural log. And then if you want, instead of writing out like this step, okay, because this is going to keep happening, the x is going to come down in front, you can cancel it out at this step and move it down. Okay, because the x is going to come in front here, and then it's just the natural log of 3, and then we'll find that decimal. Okay, and then in your notes, I'm just labeling for you which one is the exact and which one is the rounded to help you differentiate. Okay, and in your homework, you can just put each one there. That's fine. All right, and then let's look at C and see what's a little bit different about part C. So for part C, notice that you don't have e to the x, you don't have an exponential equation, you have a log equation, right? So your first step, if you have a log and it's isolated, which this is, you're going to rewrite this in exponential form. That's what we're going to do first. So we're going to rewrite in exponential form. Okay, and that's exactly what we did on the front side. We just have to remember what our base is if you have the natural log. So our base of natural log is e, and then what is our exponent? The 3. Great. So we have e to the third equals x plus 2. So that's all we did here is we just rewrote that in exponential form. And then once you do that, you're just going to solve for x. So if I want to get x by itself, I'm just going to subtract 2 from both sides. And that is going to be your exact value, the e cubed minus 2. Okay, and then let's find out what that's going to approximate to. So we have e to the third. Okay, and then make sure when you do the minus 2 that it is here instead of in the exponent. Okay, so that is your rounded answer, and this is your exact answer. All right, and then D, we have the natural log, but we have more than one. Anytime you have multiple logs, whether they're natural logs or the log, the first thing you want to do is use your properties to write as a single logarithm. Okay, so we're going to use properties to write as a single log. Okay, and that's actually what we did at the bottom of the last page. So see if you guys can condense that to a single log using your properties. Yeah. All right, how'd you do? So you're going to use the product rule, right? Did we use the product rule? So this would be the natural log, because if you have addition, remember, you can make it the natural log of 3x times 2x. And 3x times 2x is going to be 6x squared. Okay, so how do we do with this step? Using that rule. Okay, and then from there, anytime you have the natural log, you're going to rewrite it in exponential form. Okay, so I feel like sometimes we might forget that and we're like, oh, I'm not sure what to do. You're not sure what to do when it's a log. We're going to rewrite it in exponential form. So the base is e. It would be to the 9th power, and that would equal 6x squared. Okay, and some of you even did a great job solving this, even though it's more complex than the other things we did. So if you're getting x by itself, you guys tell me, because I saw you guys solve this. What did you guys do first? Divide by 6 And then after you divide by 6, you get that. Yep, we're going to say that for the end. And then what would you do to get x by itself? Take the square root. Okay, now when you take the square root, okay, you really have the plus or minus. Don't worry, you don't have to rationalize or do any of that stuff for this. We're just going to leave it as e to the 9th over 6. Okay, but because this is a log, if you have the negative answer and you plugged it back in, that would give you the log of a negative. So you can't take the log of a negative. Okay, so you reject the negative answer. Okay, and if that's just based solely on you can't take the log of a negative, we know that that would be an extraneous solution, so we're rejecting that negative answer. We'd only have the positive. Okay, so the square root of e to the 9th over 6 is the exact value. And then we're going to calculate our rounded value. So I have the square root of e to the 9th power. And then I'm going to divide that by 6. So I'm rounding that to 4 decimal places, which will give me 36.7493. Okay, so I have my exact value and I have my rounded value. All right, and then the last problem is an application problem, and some of you might recognize this, again, from Chapter 7. So Sarita deposits $750 in an account that pays 2.7% annual interest, compounded continuously. If something is compounded continuously, that means you can use which equation? Yes, which is? That would be a different one. Yes, P to the RT. Okay, yep, your bird equation. Okay, so look, it's even. There it is. So we know how to solve equations with E now. We're going to put that to the test. Okay, so she deposits $750. She has 2.7% annual interest. So we know whatever they deposit, that's going to be your principal value, your value of P. The rate we always want to express as a decimal, so 0.027. And in part A, they're asking you to find the balance of Sarita's account after 3 years. Okay, so using our model, remember model is another word for equation. The value of A is equal to 750 e to the 0.027t. And for this one in particular, we are going to substitute in t is 3. Okay, so we're going to do 750 e to the 0.07 times 3. And then anytime you're dealing with money, you are rounding to what? Yep, the hundredths place. Okay, that's the nearest cent is the hundredths place. Okay, so this is $813, and this is going to round up to 28 cents. All right, now for part B, it says how long will it take the balance? So we're trying to find how long it will take the balance in Sarita's account to reach at least $2,000. Okay, anytime they're asking you how long, that means you're going to find the time. So we're going to find T when the balance, which is A, is 2,000. Okay, so if you haven't already, will you guys set up that equation, the equation that we're going to have to solve? Okay, so in this section, we are going to be setting up an equation and solving it with logs, okay? In the past, we have done other things. So your A value is 2,000, so we're going to do 2,000 equal to 750 e to the 0.027 t, and we're going to find t, okay? Now, we have solved equations like this in other ways, but this chapter specifically, we are going to use logs to solve, okay? So you have to use those log steps. That's what I'm going to be looking for in your practice. So to get E by itself, I have to move over that 750 using division. Okay, and you can keep this just as 2,000 divided by 750. That's fine. You can reduce it as well. You get a nice decimal for this. Oh, yeah. Okay, so it's repeating. So if it's repeating, we're just going to keep it as the fraction. Okay, if it's a repeating decimal. If it's a nice one, then it doesn't matter. You can also reduce this if you want, because look, you have the zeros on the end. So sometimes I reduce it just so I don't have to write out the full numbers, because I know what the reducing is. Okay, and then once you get here, this is going to be our new step. So if you have E, what you're going to do is you're going to take the natural log of both sides. And if you want to leave some room between the equal signs so you can write that out properly, you're always putting that natural log on the left side of your value here. And then the natural log and E cancel out. Remember, they make 1. And we can bring down that exponent with the power rule. So it's that power rule that lets us bring this in front, okay? And then we're going to leave this as the natural log of 200 divided by 75, or you can leave it as 2,000 divided by 750. And then the last step is going to be to divide by 0.027. Okay, this is the exact value. The natural log of 200 over 75 divided by 0.027. Okay, and we don't want to round to the end, which is why we're keeping that fraction in there. Okay, and then I just rounded to the nearest tenth. Again, it doesn't say, so you can choose. And then this is years. All right, and then for part C, I want you guys to read through that and see if you can set up your equation. right, so it looks like we did a nice job of setting up part C. So she wants to have at least $1,000 in her account after 5 years. So you guys did a nice job of knowing that it's going to be equal to 1,000. Okay, and then it says the interest rate remains the same. What is the principal that she should invest? So you're trying to find the value of P. So it's not 750 anymore. It's going to be PE to the 0.027, and then your T value is 5. Okay, it says the interest rate stays the same. All right, so then what we can do is we can multiply those together. So we'll have 1,000 is equal to PE to the power of, we had a nice decimal, right? 0.135. So if I want to get P by itself, what can I do to both sides? You don't have to do it for this one. So we're going to divide by e to the power of 0.135. Because what that would do is cancel out. And the reason why we don't have to is because now our exponent is not a variable. It's a number. So this is just going to be a number. So the value of P is 1,000 divided by e to the 0.135. That's your exact value. And then let's find what our decimal is going to be. And again, we're going to round to the nearest cent. Yep, so you can just divide there. All right, now remember, Chapter 8 is one of the hardest chapters we've done so far, so the practice is going to be really, really important.